Welcome back. Here's the second video for today's lesson about laws of logarithms and the change of base formula. In this video, I want to simply concentrate on expanding expressions, which means I'm going to go, if we go to the previous video and the notes I had, that means I'm going to take from the condensed form where things have been multiplied and I'm going to rewrite it as addition instead, okay? Or I'm going to take a division problem and write it as separate logarithms that have been subtracted. Or I'm going to take and maybe drop down any kind of exponent to the front and say it's that number times the logarithm. Okay, so I'm going to move from the left side to the right side in this particular video. Okay, there's not a whole lot to it. All you see here is that I've got in this expression log base 3 of 5 times x. Okay, so all I want to do is simply write it as two separate logarithms, both base 3. The first one is log base 3 of 5, and the second one is log base 3 of x. That's it. On this one, I can see that I have a cubed times b. Okay, so I'm going to first start off by writing as log base 4 of a cubed plus log base 4 of b. But then what they'll want you to do in the math books and on the end of course exam is you'd want to take and realize that this is also a power property thing. See that 3 up there? I don't want to leave it as a cubed. Let's go ahead and let's drop it out in front. And let's say it's 3 times the log base 4 of a plus log base 4 of b. And that's typically going to be the format of the answer. In fact, I should probably revise my instructions to say like no exponents in your answer or something, just to remind you, okay? But that's what's going to happen is that 3 will be dropped out in front. All right? How about this? It turns out you can do the same things with natural logs with ln, okay? So I would separate this and notice that I got a couple of things on top and one thing on bottom. So it's a little bit more complicated. Ready? Natural log of x, okay? That's actually x times the cube root of y, okay, not x cubed times the square root of y. So that's I should have put a dot in there. That's my fault, okay? Plus the natural log of the cube root of y. And then because I'm dividing by z, I need to put subtract the natural log of z, okay? So I guess I need to go through and revise my notes, don't I? Put a dot in there to make sure you understand that's not x cubed times the square root, it's x times the cube root, okay? Now, we're getting close, but see, I don't want to have this here. Okay, so what I need to understand is really a cube root is really the same thing as the 1/3 power minus the natural log of z. And now that I know my product rules, I know that I can take this 1/3 and I can rewrite it as 1/3 out in the front. So natural log of x plus 1/3 of the natural log of y minus the natural log of z. And that'd be the format of the answer that we really want. Okay, so keep going until you have no exponents, no radical signs. Okay, so the big important steps here. Okay, ready? X and y were both on top, so they're both positive. Z was on bottom, so it's negative. Second step is understanding that a cube root is actually a 1/3 power. Third step is understanding I can take that 1/3 and drop it down in front. Okay, one more example. Ready? And if you can do the last one, you can definitely do this one. So same thing, right? Natural log of x cubed, because it's on top, it's positive, plus natural log of y to the 4th, and because the z is on bottom, it's minus the natural log of z squared. Now I'm just going to simply take the 3, the 4, and the 2, and I'm going to drop them down in front. So it's really 3 times the natural log of x plus 4 times the natural log of y minus 2 times the natural log of z. And there's the format of the answer I want. So you kind of see, look at the pattern here. We don't have any exponents in our answers. It's just something plus something minus something, you know, right? And maybe we have a number out in front that represents a power. So there you go. That's expanding expressions, moving from the multiplied format to the added format, or the divided format to the subtracted format, or taking the exponent and dropping it down. So that's what we want to work on. Ready? Third video will be working the opposite direction.